let's take 1, minus 3, minus 9, and minus 17. Okay, and so let's look at that. Let's see what that looks like, right? What is the difference between 1 and minus 3? Well, to get from 1 to minus 3, I actually have to subtract 4. And to go from minus 3 to minus 9, I actually have to subtract 6. And from minus 9 to minus 17, I have to subtract 8. And then the difference in the next level is going to be minus 2 and minus 2. And so again, we can verify that this is a quadratic sequence because there is a constant second difference, right? And this here is our first difference, but it's not constant. So once we see that the second difference is constant, we can now immediately say, what I'm going to do is I'm going to circle that. Ooh, that looks quite cool, right? And that over there, and that over there. Okay, and I'm going to equate them to these variables of the general formula. That's going to be 2a, that's going to be 3a plus b, and that's going to be a plus b plus c. Okay, and so there we have it. Let's see what I've got. I've got Tn equals a plus n minus, what am I doing? It's going to be Tn equals an squared plus bn plus c. And what we want to do is we want to look at this specifically. We want to say, okay, let's start with the first one. 2a equals negative 2. 3a plus b equals negative 4. And then a plus b plus c equals 1. Okay, and let's work this out. Well, divide both sides by 2 and I'm going to get negative 1. I'm going to use that negative 1 from here and substitute it in there, and I get the following. And I'm going to say, okay, that's negative 3 plus b gives me that, so b has to equal to negative 1 after some calculations. And over here I'm going to say, well, that's minus 1 for a plus negative 1 for b plus c equals 1. And this here gives me minus 2, right? And if I take that over, I'm going to get c equals positive 3, because that's negative 2, take it over, it gives me that. And so what I get is the following. I get that Tn is equal to a, which is minus 1, so it's going to be minus n squared minus n, because b is equal to minus 1, plus 3. Right, and that's going to be my general formula. Okay, so let's see, does that actually work? Minus n squared minus n plus 3. Ooh, that looks quite cool. Tn equals minus n squared minus n plus 3. And let's substitute it in. T1 is going to equal to minus 1 squared minus 1 plus 3. And what does that give me? Well, that's going to be negative 1, and that's going to give me minus 2. Minus 2 plus 3 is going to give me positive 1. So in my sequence, I've got 1. And then I'm going to say T2 is equal to negative multiplied by 2 squared minus multiplied by 2 plus 3, which is equal to the following. 2 squared is going to be 4, negative 4. Negative 2 is negative 6. Negative 6 plus 3 is going to give me positive 3. What about T3? So that's my sequence so far. It's 1, 3. And then I'm going to say T3 is equal to negative 3 squared minus 3 plus 3 equals, what does it equal? So minus 3 plus 3 is simply 0, and this is going to give me negative multiplied by 9. Okay, and so the next term of my sequence is going to be minus 9. And then finally, let's see what term 4 will equal. T4 is going to be negative multiplied by 4 squared, negative 4 plus 3. And what does that give me? Well, 4 squared is 16. Oh, let's do this part first. Minus 4 plus 3 is minus 1. And this here is going to give me negative 16, so then I get negative 17. And that's going to be my sequence, negative 17. 1, 3, minus 9, minus 17. Clearly, that's 1, 3, negative 3, yeah, negative 3, negative 3, and if I go back here, I've made a mistake because I need to see that that's negative 4, and this over here is positive 1. Negative 4, positive 1 gives me negative 3 over there, so that should be minus 3. And then you can see that clearly this formula that we found using the constructs of 2a, 3a plus b, and a plus b plus c, that's what it's equated to, right? Okay, and that's my formula.